All right, well, good morning. My name is Abby Bethune. I'm the project manager for Team Roadrunners. We work primarily on the transportation and environmental aspects of the HSTEM construction project. I'm joined by my team members, Morgan, Liz, and Nate. And today we're going to be talking to you about our traffic rerouting plan and the roof drainage system. So today we're going to start off by talking to you about our vehicle and pedestrian rerouting plans. This project is going to have a lot of impacts on Cliff Drive, which is this road right behind us, because there's going to be a crane and a lot of different equipment that's going to need to be used up and down this road. As well as that, this is a structural building and it's going to cause a lot of issues with foot traffic on campus. Following, we'll talk about the roof drainage plan and our alternative one, which is slope roof drains, and the second one has a slope roof drain and also has a green roof. And then we'll talk to you about our green roof cross sections and the benefits and our recommendations and solutions.
Okay, so for this project, we have two different plans for vehicle traffic, with the first being a single lane closure on Cliff Drive, like Abby said, which is right behind us. So. Okay, so due to its location on campus, you can see where the HSTEM building is as the star on it. It kind of created some traffic challenges on Cliff Drive. So we tried to find a plan that ensured the flow of traffic on Cliff Drive and any other roads around the area during construction. So we worked pretty closely with the CMG guys, and originally we planned to only close a portion of Cliff Drive as it was needed. So whenever the construction crew decided that maybe they needed a safety buffer on the road, or whatever they decided, we decided we were only going to close a portion of the lane for a period of time. Then we thought about it a little more, and we decided it would just be easier to close that eastbound lane basically for the duration of the project, but really only when the crane is not on site. So those dates would be from about mid-May to mid-July, and then towards the end of November until completion. And then we decided to regulate traffic during this time with temporary traffic lights. Our thought process behind that, behind using the temporary traffic lights instead of flaggers is, well, number one, they were a more cost-efficient alternative, and also it just made more sense for the weather up here, not having a person standing out in the cold.
And for the signage along Cliff Drive on the east side, we will give warning that there will be one lane closed ahead, and that there will be a temporary traffic light to give you warning that there will be one coming. And the same will be the same traffic signs will be on US 41 on the other side of the west side of Cliff Drive as well.
Okay, so when the crane is on site, those dates will be from about mid-July to the end of November. We decided that the best plan would be to completely close Cliff Drive, at least a portion of it. So during that time, traffic will be detoured down US 41s, so you can see the signs there. We don't think that'll cause too many traffic. It won't be that inconvenient on Cliff Drive, just because that's not a very heavily traveled road anyway. And a lot of lots on the road will still be accessible, which is important for any vehicles that travel down the road and don't have a way of turning back around. They can use the lots to turn around. And then the only issue that we saw with closing the road was service vehicles that still need access to the road. So snow removal, the snow plows, waste management, and then any trucks that have to drop anything off to the buildings on campus back there would still need access to the road. So luckily, most of those services are on a predictable schedule. So it would be pretty easy for the construction crew to work with them. So really, it's just a communication issue. So as long as the construction crew works with those services, they would still have access to the road. Okay, so the main staging lot that was chosen for this project is lot 1, which you can see is in the upper left corner there. Lot 3 will also be used if needed for things like trailers during construction. So those two lots, lot 1 and lot 3, are both staff parking lots. So obviously that parking is going to have to be moved somewhere else. So our plan is to move them to lot 24, which is highlighted in yellow. Obviously, that's a long way away from campus. So to make it a little bit better and a little bit more convenient for those parking in lot 24, shuttle service will be provided to move people to and from campus. And then also just another side note, lot 2 is connected to lot 1. So by closing lot 1, that also takes that parking away. So that parking would also have to move to lot 24. And then since it is so much further away from where those lots originally were, we would have to work with transportation services as the project grew closer to try to find a better alternative for parking.
In addition to the one-lane closure and road closure behind Cliff Drive, we also created a pedestrian detour plan. With this plan, we decided that the sidewalk behind the construction site on Cliff Drive will be closed to help reduce foot traffic. We also have a temporary fencing around the construction site to help keep any debris in the workplace zone and hopefully keep it from spreading to the rest of campus. In addition, for the exterior doors on the Kenside building on the east side will be closed and locked so that no student, faculty, or anyone else going through the building won't accidentally end up walking onto the construction site, not only for their safety, but the safety for the construction workers as well.
So now we're going to get into discussing our roof drainage plan for the top of the HSTEF building. So our goal with designing the drainage system is to provide a LEED certified and sustainable, as well as a cost-effective way to drain snowmelt and rainwater off the top of the HSTEF building throughout its lifetime. So we've designed 2 proposed alternatives. The first one is a slope roof drainage system, which uses slope drains to get the water off the roof through pipes down the HSTEM building. And the other one will also have that same methodology, but it will also have a free roof added onto it to ease a little bit of the drainage and reuse it and make it more LEED certified.
So for our drainage calculations, we had to determine the number of drains that we were going to place on top of the roof along with the pipe sizing for those drains. So in order to do this, we used a rational method to calculate the runoff up on the roof, and we designed for a 50-year storm. So using the rational method, the main equation is for the maximum rate of runoff, which is the rainfall intensity multiplied by the roof area of the HSTEM building, multiplied by a runoff coefficient on the roof. So in order to calculate the rainfall intensity, we had to find the time of concentration for a 50-year storm. We did this using these 2 equations shown up here, and we found that our time of concentration was 49 minutes. We then took this value and plugged it into the NDOT rainfall intensity duration tables for a 50-year storm and found the intensity to be 2.25 inches per hour. So once we had our rainfall intensity, we had to calculate the roof area of the HSTEM building, which we just used the architectural drawings that were provided to us. And based on those dimensions, we found that the roof area was just above 18,000 square feet. Next, we had to calculate the runoff coefficient. This is the only value that changed between the 2 alternatives. So for the first alternative, it was just based on the roof panels. So we found it to be 0.95. And then for our second alternative, since we were implementing a green roof, we had to use a weighted coefficient, which we just calculated by taking the area of the green roof and multiplying it by a green space coefficient and then adding it to the slope roof coefficients. And we found that to be 0.865. So once we had all our initial variables for our equation, we plugged it into the maximum rate of runoff equation. And for our first alternative, we found the total runoff to be 404 gallons per minute. We then divided this number by the total number of drains that we plan to place up on the roof to find the capacity of 1 drain. And we found that 1 drain for this alternative would hold 34 gallons per minute. And then for alternative 2, we found the total runoff to be 365 gallons per minute. And then each drain could hold 37 gallons per minute. Once we had the capacity of 1 drain, we plugged these values into this table shown here in order to size the pipes in both the horizontal and vertical directions, which we'll go over those results in the next couple of slides. So for our first alternative, it was just a basic conventional roof design using tapered insulation panels that slopes into 12 roof drains. We decided that we were going to place 3 of these drains on top of the penthouse that is on the roof. And then we followed the minimum building code and put those panels at a 1/4 inch per foot slope. And based off the calculations that were just explained, we found that the vertical drains need to be a minimum of 2 inches in diameter and hold 34 gallons per minute. And then the horizontal drains need to be a minimum of 3 inches in diameter and hold 87 gallons per minute. So here's our AutoCAD drawing showing where each roof drain is planned to be placed along with the slope of the installation. And as you can see, everything is meant to slope to the center of the drains. So then for our second alternative, we implemented a green roof. And in order to meet the minimum required for LEED certification and help our environmental team hit that gold level certification, we had to design a roof with the green roof that covers 25% of the roof area. And based on the areas that we chose, we were able to come up with a plan that covers 34% of the roof. And we did this by removing 2 of the center drains on both sides of the penthouse, and then taking the 3 drains on the south side of the building and moving them up against the wall. And this would change the panels from a 2-way slope to a 1-way slope. And then based off of our runoff coefficients and calculations, we found that the diameter for both the horizontal and vertical directions of the storm pipes need to be 3 inches. And then the vertical drains will hold 87 gallons per minute, and the horizontal drains will hold 79 gallons per minute. So here's our AutoCAD drawing for the second alternative, showing the new placements of the drains along with the green area, which is the cross hatching shown here.
So now I'm going to actually get into the design and the layout of how a green roof works to give you a little more understanding about it. It's also important to recognize what LEED certification actually stands for. LEED certification is a design certification that is used to help buildings be more environmentally friendly, both towards the environment and those who work within the building. So this, my green roof design had to be designed to fit a structural standard of 100 pounds per square foot. So with that being said, we could only do a 5-inch cover of soil on the top, and this will be in the actual growth layer, which is right here. Also, this design is a variable design because each layer, depending on where you source it from, it's going to have a little bit different thickness. So the growth layer is where the actual plants will grow, and these will all be native plants to the area so that they can survive the harsh winters up in Houghton. The following layer is a filter layer. And whenever you're working with soil, there's always fines and toxins that can be developed in the soil. And this filter layer is used as a protection layer to keep any fines that could be hazardous to the rest of the system out of the roof. The following layer is a drainage layer. And if you think about this, it looks a little bit like egg cartons, and it's used as an area for water to be held. And this water will then be used when the growth layer needs water to feed on to help its plants grow. The following layer is a protection layer. This is also used as a backup to the filter layer to ensure that no more fines or any extra water gets through to the waterproofing layer or the concrete roof. The waterproofing layer is used as that final layer on top of the concrete roof to ensure that there's no flooding or any drainage that goes into the actual structure itself. And it keeps it as its own system on top. So the green roof has a lot of benefits. Not only does it help us to be LEED certified, it also helps us with aesthetics, and it is a safe way to provide roof drainage that's also a little more environmentally conscious and will help reduce carbon emissions from this building. The downfalls of a green roof are that this is a little more costly to design, but despite that, it has its long-term payoffs in the end. If it's not designed correctly, it could have potential for failure and not work adequately for what we would like it to do. Another thing we discussed in terms of the drainage system on ways that we could be more environmentally conscious and add points to our LEED certification is the idea of a rain garden. So what a rain garden is, it's an area on the ground below a building where water can drain off into as it's coming off of the building. This could be used as an alternative to tapping into the underwater storm sewers, and it would also be more cost efficient. Not only does this help with cost efficiency, but it would also be an economically smart decision. It would also help recharge groundwater, and it reduces the risk of flood. Anytime you add in more concrete to your building, it's going to have impermeable impacts. And impermeable impacts are what make floods happen and reduce the amount of green cover in an area. So anytime that you can add this back into your environment, it's beneficial to the whole community itself and will help reduce the risk of flooding. So in terms of our final suggestions for the green roof or for the Michigan Tech HSTEM building, We have decided to use alternative 2 for the drainage system because it adds that LEED certification and it's more beneficial to the structure itself. So to achieve this, it's going to cost more initially, but in the long run, it's going to be beneficial to the building itself and our Michigan community as a whole. Thank you. So, if you have any questions?
Great job. So, any questions? We have about 6 people online, chat stuff. Do any of you have any questions?
We have some questions.
Let me go ahead and read this one so you can answer. Okay, I'll go ahead and read since.
Okay.
And these are the, okay, Dave Nelson, let's see, says, wow, that is a significant impact on full-time employees in the admin building. But this is the rerouting of the parking, I believe. Did anyone have any conversation with any of those employees? Will this have any impacts on union contracts?
We did not, no. So we did not talk with any employees. I'm glad President Kovac left. But like we said, as the project grew closer, we would try our best to find another alternative. Parking is scarce on campus as is, so it's an unfortunate happening that parking has to get moved, but everybody wants the building, so some sacrifices have to be made.
Yeah, that was definitely a challenge with the site, and this group worked with the construction management team on staging and how we deal with that. And so this is
Back
just,
and forth.
yeah, so
Yeah.
this is just one hypothetical. It's a solution that would work.
It's a solution. I guess I have an idea of what we could do. I mean, I know it's not the most beneficial to have everyone go up to the lot up like lot 24. So another area we could do is we could overtake, there's those park mobile, like the open lot that's used for people who come and tour, and that could be turned into a faculty lot as well. But then we'd also lose that parking for guests.
Yeah.
on campus.
Somehow there's going to be.
And there's gonna be a
Yeah.
downfall.
It looks like Dave had some more. Well, we kept on. Dave, continued questions. So could you put your staging area in lot 24 and use just-in-time delivery to the construction site?
Yes, I think the CMG guys are going to talk more about that, so I'm not going to steal their thunder, but yeah, that is an option.
How will your drainage be impacted by ice and snow, especially during spring thaw?
So during the spring thaw, there is gonna be more, like the drains need to be able to hold more, so that's why we propose the second alternative, since it holds about like 87 gallons per minute rather than like the 34 gallons per minute. So we think that'd be sufficient enough to hold, like, handle the spring thaw.
Dave, did you have any other questions, or was that sufficient?
That's sufficient. I think one of the things I was concerned about is that there's a lot of times when drainage gets blocked in the spring. And then you get a big rainstorm, and where does the water go?
Right.
I think that would be something critical to look into moving forward, especially I know I've dealt with that. That can cause a lot of issues with flooding and just dripping into the building itself. So making sure that there's maintenance being done and even shoveling off the snow, if we have people who run maintenance on the building, would be beneficial.
Yeah. Could you even put like, I know they have those snow melt systems.
Yeah.
Roof snow melt systems, that could be a possibility too, yeah. I don't know what they use on the existing buildings here, but
Yeah. Interesting.
is that sufficient, Dave?
Yes, thank you.
Thank you. Any other questions?
So you said it's a little more costly to build this. So did you look into the difference between those prices, or you just know it's more costly?
We did. So the CMG guys can talk a little bit more about it. So they ran all the numbers for this project, and I believe you guys know the numbers.
Well, I mean, it's obviously just adding, I'm not sure exactly how much you put in there, but it's just adding more and more costs that would be.
Yeah, so for about every like pound burger I think put down, it's gonna be about, so probably $10 per pound. And this is 34% of a 1,800 square foot roof. and it's 100 pounds per foot, so that number really racks up.
And then we would also have to bring the crane back on site.
And the other protection layers that go underneath it would also add a lot of costs.
Any more questions? This is great. We're getting questions.
Yeah.
Do you see the growth there would just be 5 inches?
Yeah, so the growth layer would be 5 inches.
So did you look into what plants you used on the building?
I did a little bit, so we were thinking more like small shrub plants. There's a whole list. I mean, if you're interested, I have a list. So we worked with the group down that did the GLRC. They had a lot of very small, like aggressive plants that can withstand the winter. There are a lot of spiky, like bushes.
Any more questions? Great. So we have about 5 minutes until the next presentation, and I would, so we'll take a quick 5-minute break. So it looks like team number 1, some of you scattered. I would, if you are actually in this class, I would ask that you stay and support the rest of your teammates. But so yeah, let's take 5 minutes. So thank you again.
They did. There's 2 more for our.